Okay, welcome back, guys. Let me just get the question from 2020. Uh, so we did this question. So now let's do question number 7. Question number 7 says the define Lenz's law. So let me just search what Lenz's law states, and then we can do the calculations. So I see that definition is like 2 marks. So don't forget to study your definitions and calculations as well. So let's do these three questions. Copy. Okay, so it's just loading, and we are back. So let me just paste it over here. This is the question. Define Lenz's law. So if I search on the internet, it states that Lenz's law states that the direction of the induced EMF will be such that if it were cause a current to flow in a conductor, an electric circuit, then the current would generate a field that would oppose the change created it. Okay. So Lenz's law is basically saying that if a current passes through a wire, right, and there's like these magnetic fields, right, and if you pass like, let's say for instance, an something with an current flowing through it, there's like a magnetic field that would um, generate a field that's opposing this field. Do you understand what I'm saying? So basically, like it's like magnets where because the one is um, has a current, it's going to now have like a field that's going to be opposite to the one that doesn't have a current. So let's do question 7.2. Question 7.2 states that the magnetic coil of a car rotates at 1300 RPMs. The coil has a winding of 800 and a length of 70, a width of 90 millimeters, and the pole shoe has an area of 0.4 meters squared, and it moves through a magnetic flux of 35 microweber. Determine the EMF. So let's write all the given. So what's given to us is RPM, which is 1300 RPM. The number of windings is 80. The length is 0.07 meters, and the width is going to be 0.09 meters. It has an area of 0.4, so an area of 0.4 meters squared, and it moves through a flux density of, so they want us to get the EMF. So let's write the question down, EMF. And the last thing states that the magnetic flux is 35 microweber. So the flux is equal to 35 microweber. Weber. How do you guys pronounce that? So how do we calculate the EMF? To calculate the EMF, we know that The EMF is equal to the density multiplied by the length multiplied by the voltage. But we know that there's also a sine theta here, but we just use the maximum. So this can be 1. So who knows what sine 90 and sine 0 is? Because if you forget in the exam room, you can just type into your calculator sine 90 is equal to 1, right? So that is where the maximum is. Sine 90 equals 1. That's the maximum. So we'll be using 1 year. So if they give you a question where it's not perpendicular, then you're going to have to remember that there's a sine theta over here. So let's continue with the question where they want us to calculate these variables, and we can see that we do not have this, nor do we have the voltage. So what's going to happen is we're going to have to calculate each of them individually, right? So let me draw this windings and whatnot so you guys can understand. Let me add another page over here. So let me draw a diagram that you guys can use in the exam venue. So I like to draw this diagram of um, like an electromagnet motor, you know. So over here we have like a shaft going through here, and we have like current going through the wire, right? Guys, remember the inside of a motor. This is a shaft, so I'm gonna remove the shaft so it doesn't completely confuses anyone. And I'll just draw this a bit bigger. Let me just draw this. Okay, so this is how I used to draw it. I mean, I still do draw it like this, but this is how I did it back in the other days. Draw it like this year. So we see that, okay, let me explain to you guys. These lines are parallel. So we know that sine 0 is equal to 0. So we can ignore those ones. And these lines are going to be perpendicular. So sine 90 is equal to 1. So let's draw this thing, get rid of these ones. So we know that inside an electric motor, we have something as a magnet. So we have a north and we have a south, north and a south. And then we have a current moving through this wire. And then it says we have armature, 80 windings, right? So what that means is that there's 80 wires going around the motor. And we know that an increase in wire would be an increase in strength. That's why, like inside a motor, you would see that there are a lot of wires wrapped around each other instead of just having a single solid wire. This allows it to increase its strength with the number of wires inside of a motor. So continuing for the um so this year is going to be the length, and then this year is going to be the width. So we got that number of windings, and then there's a shaft here, remember, and this is going to rotate angular, and the speed is 1300 rpm, right? What else is missing? So we got an area. So I think this area is the area of the wire. Pole has an area. The pole shoe has an area of, yeah. So I think this area is 0.4 meters squared. So basically what they are saying is, so you have like a motor here, right? So this area here of the motor is going to be that area of 0.4 meters squared. 0.4 meters squared. It is that area of the motor. This is the side view of a motor. Let me draw this. Hope you guys understand. Shaft coming out of the motor. Then this face here, that area, 0.4 meters squared. So this is the question. So the question wants us to calculate the EMF. So we have to first find the length. So the length is going to be the total length. Sorry, total length is going to be the length times the number of turns times 2. Okay, so the length, this distance here is how much? 0, 0.07, 0, 0.07. And then the number of windings is 80, right? And then multiply by 2. So now the answer would give us, if I look in my calculator, we have 11, 2, 11,2 meters. So now let me explain to you guys what this means. This length is the length of the wire. We do not add this length and we do not add this length, because remember that these two wires are parallel to the batteries. You see these batteries, right? They have an electric field from north to south, north to south. Remember your right hand and left hand rules. If you guys want to follow the current and then north to south, remember that these ones are also going in the same direction as the magnetic field. So they are going to be sine 0, which is 0. But these ones here are perpendicular. What does it mean? When they're perpendicular, sine 90 equals 1. So then we're only going to use this length and this length. So what our formula is, it's that length, number of windings. So remember, there's not just one wire, there's multiple wires here and multiple wires over here. So that's why 80 wires. So number 2, why is it 2? Because there are two conductors. Here's a conductor here and a conductor here. So don't forget to multiply by 2 because of the two conductors. Let me just remove the slides here. And let's move on to rotation. So the angular rotation is equal to what? 2 pi n over 60, which is 2 pi 80 over 60. Wait, RPM is 1300. Guys, let's just take a quick break. I need to just refresh and come back. If we can continue like just 5 minutes. You can so long get the answer over here, and we'll continue in about 5 minutes. Pause recording.
I'm taking a break. Let me have that for a minute. Huh? Let me have that for a minute. Listen up, huh? They already saying you're making noise in the class. Already what? They said that you're making noise in that class. Remember when you were there? Did they hear my voice? They know. They called me by my name. No, I called you by your name. Oh, they don't look at the Yeah, I have the recordings. But it's not enough. Yeah. Okay,
Okay,
guys.
guys,
Sorry for
sorry
that.
for that.
Welcome back.
Welcome back.
Like,
Like,
I'm
I'm kind of,
like
like
rushing through
rushing through
this. I
this.
know
I
I'm
know I'm
rushing
rushing
through
through
this,
this,
but
but
like
like
a lot
a
of
lot
things
of
are
things are
happening.
happening.
So,
So,
welcome back.
welcome back.
Let's
Let's
continue.
continue.
Are there any
Are there any
questions on
questions
this
on this
diagrams
diagrams
or
or
any
any
misunderstandings or
misunderstandings or
questions?
questions?
Okay, so
Okay,
let's
so let's
continue with
continue with
the
the
what's the
what's the
problem.
problem.
So we got
So
the
we got
total
the
length.
total length.
This is
This
our
is our
total length
total length
that we
that we
calculated
calculated
from this
from this
diagram. If
diagram.
you
If
want
you
to
want to
copy the
copy the
diagram,
diagram,
sure, no
sure, no
problem. That's
problem.
what I
That's what
use.
I
That's
use.
what you
That's
can
what
use
you can
also
use also
as an
as
understanding. But
understanding. But
most of the
most of the
memos
memos
they do not
they
have
do not
any
have any
diagrams.
diagrams.
So I
So I
think
think
I'll
I'll
in
in
this
this
what you call
what you
this.
call
Sorry,
this,
I'll
sorry,
do
I'll
this
do
last
this last
questions
questions
and then
and
I'll
then
post a
I'll
memo
post a
on the
memo
group.
on the group.
So I
So
don't
I
want to
don't
keep
think
you
I'll
that
keep you
long.
that long.
Um,
Um,
the
the
question that I
question
had
that I had
is
is
I know you guys
I
are
know you guys are
writing on
writing on
Monday.
Monday.
Is
Is
there
there
do you guys
do you
want me
guys
to
want me
give a
to give
class
a
on
class on
Sunday
Sunday or not?
or
Oh,
okay,
okay,
just
I'll just
post a
post
poll
a
poll
a
on the
poll
group.
on the
I
group.
think that
I
should
think
be
that should be
better
better if
people actually
people
want the
actually
class
want the class
because
because
I haven't
I
gotten
haven't
any
gotten any
questions from the
questions from the
students.
students.
So
So
it's better
it's
if
better if
we
we
just
just
have a
have a
1 hour
1 hour
session
session
tomorrow.
tomorrow.
So when you
So when
punch
you
it in your
punch it in your
calculator, I
calculator, I
think you
think
get
you get
136
136
radians
radians
per
per
second,
second,
revolutions per
revolutions per
second.
second.
So it
So
becomes
it becomes
radians.
radians.
Okay.
Okay.
So
So
the next
the
step
next
is
step is
to
to
get
get
the
the
velocity.
velocity.
Oh,
Oh,
so
so
yeah,
yeah,
about that
about that
formula,
formula,
velocity
velocity
is
is
angular
angular
times
times
radius.
radius.
So we have
So we have
136
136
multiplied
multiplied
by
by
radius.
radius.
Okay.
Okay.
So this is our
So this is
width.
our width.
So
So our
radius is going
radius
to be
is going to be
divided by
divided
2.
by 2.
So it's
So it's
0.009
0.09
over
over
2.
2.
So
So
let me just
let me just
indicate to you
indicate to you
guys
guys
from the
from the
center of the
center of the
shaft,
shaft,
end of the
end of
shaft,
the shaft,
that's the
that's the
radius.
radius.
Going to
Going
our
to our
calculations, we
calculations,
have
we have
0.009
0.09
over
over
2,
2,
and the
and the
velocity is
velocity is 6,122
6,122 meters
meters
per
per
second.
second.
So let's
So
just
let's
make
just
that
make that
6
6
meters
meters
per
per
second.
second.
The
The
next
next
fast to
fast to
calculate
calculate
is the
is the
magnetic
magnetic
density, and
density,
we
and
know
we
that the
know that the
magnetic
magnetic
density
density
is
is
equal
equal
to
to
the
the
what is
what is
it?
it, 0.3,
The
the
flux
flux
over
over
area.
area.
So the
So the
flux was
flux was
given to
given to
us
us
35
35
microwevers,
microwevers,
and the
and the
area
area
was
was
0.4.
0.4.
Let's
So
put that
let's put that
in
in
0.4
0.4
meters
meters
squared,
squared,
and the
and the
magnetic
magnetic
density is
density
equal
is equal
to
to 0.087
0.087 tesla.
Tesla.
Don't forget
Don't
your
forget
units,
your units,
guys,
guys,
on Monday's
on
question
Monday's question
paper,
paper.
and then
And then
our answer
our
for
answer
the
for the
EMF
EMF
is equal
is equal
to
to
the
the
magnetic
magnetic
density
density
times the
times the
total
total
length
length
times
times
the
the
velocity.
velocity.
So we
So we
have
have
at another
at
page
another page
0.087
0.087 5
multiplied
multiplied
by
by
the
the total
total length
length
of
of
11,2
11,2
multiplied
multiplied
by
by
6.
6.
So we
So we
have
have
total length
total length
11,2
11,2
and the
and the
velocity of
velocity of
6,126.
6,126.
So the
So the
EMF is
EMF
going
is
to
going to
be
be
electromotive
electromotive
force
force
going to
going to
be
be
6
6
volts.
volts.
So we are
So
done
we
with
are
this
done with this
question, and
question,
the
and the
answer of
answer
the
of the
EMF is
EMF is
6
6
volts.
volts.
The
The
primary and
primary and
secondary
secondary
winding of
winding of
the
the
induction coil
induction coil
is
is
1,508,
1,508,
3,800
3,800
turns
turns
respectively. The
respectively. The
current
current
of
of
0.5 amps
0.5 amps
generated
generated
a
a
total
total
flux
flux
of
of
800
800
Weber
Weber
in a
in a
primary
primary
winding.
winding.
So
So
the
the
thing
thing
is like
is like
our class
our
has
class has
ended one.
ended
I won't
one.
have
I won't have
time to
time
finish
to
this
finish this
question,
question,
but I'll
but I'll
explain to you
explain to you
guys the
guys the
diagram
diagram
that we
that
have.
we have.
So
So
basically, the
basically, the
diagram would
diagram would
have
have
two
two
of these
of these
solenoids, kind
solenoids,
of
kind
a
of a
thing,
thing,
and
and
then
then
the
the
one
one
would have
would
a
have a
current
current
flowing through
flowing
it.
through
So
it.
we have
So we have
3,000,
3,000,
3,800,
3,800,
1,500
1,500
current
current
amp and the
amp and the
flux.
flux.
Okay,
Okay,
so the
so
first one has a so this one has 3,800 and this one has 1,500. So then they have a
they have a
flux
flux
of,
of,
can't
can't
remember,
remember,
but
but
this is
this
how
is
you would
how you would
draw it.
draw it.
These are the
These are the
windings,
windings,
and you will
and
have
you will have like
3,800 over
3,800 over
here.
here.
Then you will
Then
have
you
a
will have a
current
current
flowing through
flowing through
here.
here.
That means
That
that
means
there will
that there will
be
be
an
an
electric
electric
field
field
generated here.
generated here.
So this is
So
like
this is like
an
an
electromagnet.
electromagnet, right?
This is like
This
an
is like an
electromagnet.
electromagnet.
This is like
This is
your
like your
copper
copper
or
or
cast
cast
iron. So
iron. So
here's
here's
another one.
another one.
It will
It
have
will have
this is
this. Oh,
that's your other
that's your other
windings,
windings.
1,500.
1,500.
So this
So
is
this is
the
a
magnetic
magnetic
field. This
field.
is your
This is your
current going
current
through
going through
here,
here.
and our
And our
current. Let me
current, let
just
me
give
just
this
give this
thing
thing
4.5,
4.5,
4.5
4,5
amps,
amps.
and
And
flux is
flux is
800
800
microwebers.
microwebers.
800
800
microwebers.
microwebers.
Let's
Let's
go
go
to
to
the
the
question.
question.
Question
Question
says
says
the
the
induced in the
induced in the
primary
primary
winding.
winding.
So
So
you're going
you're
to have
going
a
to have a
primary
primary
and a
and a
secondary.
secondary.
So the
So the
primary is
primary
going
is
to
going to
send to
send
the
to the
secondary,
secondary,
right?
right?
So
So
once the
once the
primary
primary
sends to the
sends to the
secondary,
secondary,
we're going
we're
to
going to
have
have
to
to
find
find
the first
the
question.
first question. What was the question?
The
The
inductance in the
inductance in the
primary
primary
winding.
winding.
So they want
So
to
they
know
want
the
to know the
inductance.
inductance.
So for
So for
inductance, it's
inductance, it's
L
L
equals to
equals to
the
the
flux
flux
multiply
multiply
number of
number of
windings
windings
over
over
the
the
current,
current,
right?
right?
And then you'll
And then
get
you
an
get an
answer
answer
in
in
Henry.
Henry.
Henry,
Henry,
right?
right?
For
For
capital
capital
H.
H.
And
And
then the
then
next
the next
question
question
is
is
um,
um,
induced
induce
EMF in the
EMF in the
secondary
secondary
winding
winding
if the
if the
current in
current
the
in the
primary
primary
winding
winding
decreases
decreases
to
to
0,
0 or
0.5
0.5
seconds.
seconds.
So
So
0 or
0
0,
or
0.5 seconds,
0.5
and they
seconds,
want
and
the
they want the
EMF,
EMF,
and we
and
know
we
that
know that
the
the
flux is
flux is
multiplied by
multiplied by
the
the
number of
number of
windings
windings
over
over
the change
the
in
change
time.
in time.
So the
So
first
the
question
first question
is,
is,
let's see,
let's see,
the
the
induced in
induced
the
in the
primary
primary
winding,
winding,
right?
right?
So
So
let's see
let's
here.
see here.
This would
This
be
would be
our
our
primary,
primary,
and this would
and
be
this would
our
be our
secondary.
secondary.
So
So
primary
primary
windings, let's just
windings,
go
let's just go
to
over the question.
a
A
current of
current of
4.5 amps
4.5 amps
generates a total
generates a total
flux of
flux of
in the
in the
primary
primary
winding
winding
0.4.5
4.5, 800.
Okay,
Okay,
so
so sorry guys.
this
This
current
current
is
is
in the
in the
primary, this
primary,
is
this is
secondary.
secondary.
The
The
current
current
flows through
flows
the
through the
primary.
primary.
My
My
mistake,
mistake,
guys.
guys.
The
The
current flows
current
through the
flows through the
primary,
primary,
and then
and then
there's
there's
an
an
electromagnetic
electromagnetic
force,
force,
like an
like an
electromagnet, right?
electromagnet, right?
And you can
And you
see that
can
it's
see that
very
it's
close
very
to this
close to
one.
this one.
So it's
So
going
it's going
to,
to,
it's
it's
going
going
to
to
induce
induce
like
like
electromagnetic
electromagnetic
force.
force.
Electromagnetic force
Electromagnetic
is what?
force is what?
Voltage, right?
Voltage, right?
So what's
So what's
happening is
happening is
magnetic
magnetic
force is
force
being
is being
converted
converted
to
to
electrical.
electrical.
So
So
this one is
this
going to
one's gonna
be
be
1500
1500
bam,
bam.
and this is going
And
to
this is
be
gonna
what?
be what?
Current
Current
is
is
4.5.
4.5.
So it's going to
So
be
it's gonna be
4.5,
4.5,
and you
and
already
you
have
already
the
have the
flux
flux,
800
800
microwevers.
microwevers.
So the
So
next
the
one
next
is
one is
EMF.
EMF.
What does it
What does
say?
it say?
Um,
Um,
induced
Induced
EMF in the
EMF in the
secondary
secondary
winding.
winding.
So
So
secondary
secondary
winding
winding
is
is
over here.
over here.
So all
So
we
all
have
we
here
have here
is
is
number of
number of
windings.
windings.
So
So
that was
that was
given.
given.
So
So
the
the
windings
windings
given.
given,
The flux
the
remains
flux
this
remains this
constant,
constant,
and
and
time is
time
given
is
in the
given in the
question.
question.
And
And
that is
that
how
is
you
how
get
you get
the
the
voltage
voltage
from
from
electrical
electrical
to
to,
no,
no, sorry,
from
from
magnetic
magnetic
to
to
electrical.
electrical.
So
So
EMF is
EMF
like
is like
electrical
electrical
voltage.
voltage.
And
And
thank you for
thank you
joining
for
the
joining the
class. I hope
class.
you
I
guys
hope you guys
learn
learned
something,
something,
enjoy the
enjoyed the
class.
class.
And
And
sorry for
sorry for
rushing through
rushing
this
through this
lesson,
lesson,
but I hope
but
you
I
guys
hope you guys
understood the
understood the
diagrams,
diagrams and
the
the
lessons, the
lessons, the
calculations.
calculations.
Unfortunately, I
Unfortunately,
have
I have
to
to
go to
go
other
to other
plans.
plans.
Are there any
Are there any
questions?
questions?